Good morning, everyone. My name is Shivshankar Vutlapalli, and today my project topic is POS tagging, which is parts of speech tagging in information retrieval. Uh, let's dive into the topic. POS tagging, as the name suggests, parts of speech tagging gives grammar roles like noun and verb to each word, and it is used in information retrieval to better understand the searches and organize documents. So it refers to assigning the grammatical labels to each word in a text, like noun, verb, or adjective. And these techniques is used in the information retrieval to improve query understanding, context indexing, relevance ranking. And it also what it does is it helps us in turning the messy text into structured information, and also it enables semantic aware retrieval systems. The next slide is importance in information system. So POS tagging supports smarter query suggestions and also boosts search results accuracy. It also helps in identifying the key entities and meaningful phrases in a text. So it also like and helps in it helps in a process like query expansion, wherein it helps us identify the synonyms or terms related to the same category. And also the NER, it like named entity recognition, wherein PERS helps us in correctly identifying the entities, and which is also helps in improving the precision in entity-based search. And it also helps us in enhancing language understanding for improved semantic search, which is language modeling. And also it helps us in the phrase recognition, which helps us in which is nothing but identifying the meaningful phrases in a text. So we have the POS tagging methods, which are rule-based tagging, statistical-based tagging, deep learning tagging, and multilingual POS tagging. So in the rule-based tagging, we use handcrafted linguistic rules. Within statistical tagging, use HMM, CRFs, maximum entropy models, and the deep learning tagging use by LSTM transformer like BERT. And the last thing, the multilingual POS tagging addresses the challenges of tagging across different languages with its own grammatical rules and syntactic structures. We'll learn about this tagging methods like briefly, like in detailed version in the next slides. So the first thing is rule based versus statistical based. So let's dive into the rule based tagging. So rule based tagging, it relies on manually defined linguistic rules like to identify the grammatical category of words based on the morphology and also the context. So this system uses the dictionaries and heuristics to resolve ambiguities. So one of the most notable rule based system is Entwog tagger, which is developed for Finnish. And the advantages of rule-based tagging are it is easy to understand, but the main disadvantage is it's limited in flexibility. So coming to the statistical tagging uses probabilistic models trained on annotated corpora. Like the common approaches are HMMs, which are hidden Markov models, and and maximum entropy models, and also CRFs, which is conditional random fields. So what happens is this makes this model consider the probability of given word, and it's like it makes this it makes them data driven, flexible, and it can perform under like across the various domains. So that's a major advantage of it, like it because it's adaptable, data driven, and learns from the labeled data set. So even if you compare both rule based and statistical tagging performs better with sufficient training data. And the next slide is deep learning based POS tagging. So as in the deep learning based POS tagging, it approaches the POS tagging to use models like bidirectional LSTMs and CNNs or the transformers. So these models are trained on large corpora, and these are also capable of learning contextual representations of words, which may lead to the accurate tagging. So uh, mainly in information retrieval, deep learning models like BERT, like bidirectional encoded representation from transformers, use contextual embedding and a fine-tuned language representation to improve to improve the understanding of both queries and the documents. So these deep learning models, they outperform traditional and statistical models in many scenarios, because like when they are dealing with the domain specific models, so they outperform them. And if you consider deep learning based is rather better, I mean, it performs better and the fast than statistical ones. So it delivers better accuracy in complex or specialized text, and it also boosts semantic interpretation in the information retrieval system. The next slide is multilingual peers tagging. So in the multilingual peers tagging, we address the challenges of tagging across different languages. As the name suggests, it's across different languages, calling its own grammatical rules and the text and the syntactic structures. So many here what happens is many resource language lack annotated corpora, so which makes it even more difficult to train accurate model. So we use the main approach to this problem include transfer learning or cross-lingual embeddeds, or like multilingual models which use mbert. So mbert is nothing but multilingual BERT. So or we also use XLMR, which is cross-lingual robota. So the tagging consistency across languages is critical for multilingual IR systems. So here the universal like appears tag set is standardized tag set, like which is used across multiple languages, and it also helps us to enable better cross-lingual NLP research. So here we also, like as I've told you, we it supports multiple languages and also uses universal tag set, which helps us, which in turn helps us to maintain the consistency across the languages. That's it. And the next one is integration with vector space models. So here the integration with vector space models, it gives higher importance to keywords, key content words during retrieval. It also enables phrase level search using syntactically tagged terms, and it enhances semantic matches between queries and documents. Here vector space models, we use VSMs such as TF, IDF and BM25. They represent both documents and queries as vectors here in high dimensional space. So peers tagging can be integrated into these models to weigh terms based on their uh, syntactic role. Yes, for instance, nouns and verbs typically carry like semantic weight than articles or conjunction, and can be given higher weight in the vector representation. So peers tagged phrases can be indexed as multiwords terms, because I mean, we do that because to support the phrase based retrieval. And the next one is role in query expansion. So here, query expansion is a technique we use in information retrieval to improve search performance by reformulating user queries. And here, peers tagging enhances query expansion by identifying the grammatical structure and the key content word, like nouns and nouns or verbs within the query. For example, we have a query like we want a smartphone with a good camera, the good storage. So that we can modify by saying like a phone, the phone or a smartphone, camera, storage. So here, camera and the smartphone and the storage are nouns which can be expanded with relative terms, like camera can be said as mobile phone, or sorry, smartphone can be said as mobile phone, camera can be said at lens, and the storage we can say is like expandable memory or something. So here here we do that because to avoid the inclusion of irrelevant function words. And additionally, syntactic parsing using peers tags enables advanced methods such as dependency based expansion, which can preserve the structure and the meaning of original query. So peers tagging identifies the main syntactic elements in the query, like as I've said before, and then it helps us expand queries intelligently using synonyms or semantic equivalents. So that's how it says, like maintains original query structure during reformulation. So in document processing for IR, peer tagging plays a vital role in both parsing and also understanding the text. So by labeling parts of speech, systems can extract the key information, which is like the what are the noun phrases in it and what are the verb construct available, which can typically have more relevant. Which are typically more relevant for the indexing and the retrieval. So here parts of speech tagging in document processing supports indexing and retrieval using meaningful phrases. So which these also helps in creating more effective document representation, because they filter out the less meaningful content like the prepositions or the determiners. So these we do it to enhance relevance. And also additionally, parts of speech tags supports a text summarization, sentiment analysis, and also concept detection in documents, which helps us enabling the advanced IR features such as like facet based search and topic modeling. Like it enables it. And also peers tagged documents also support more precise face matching and ranking during retrieval, improving the search accuracy. So these documents are pre-processed to identify noun and verb phrases that form the core semantic units. So here we also have like we also have peers tagging in multilingual IR, which requires processing text in multiple languages. We have like a peers tagging in question answering system. So it's just as the name suggests, in question answering system, peers tagging plays a vital role in parsing the structures of questions and identifying the type of expected answers. And we also have integration with knowledge graphs, wherein knowledge graphs are structured information of entities and the relationships. So these are the techniques which are used in the POS tagging. And the next slide is going to be, so the next is tools which are used in POS tagging. We use the NTLK, which is like classic Python NLP toolkit. We use Spacey, which is high performance Python library optimized for speed. We use Stanford NLP, which is Java based toolkit. We use TextBlob, which is again the beginner Python library. And we use RNLP, which is like deep learning framework based on PyTorch. We use like these also like we use support role-based statistical deep learning models. So the tools like these are the about tools which use for the POS tagging. And so the functions of the POS tagging. So as like the functions are tokenization, which will split the raw tokens into the raw text into the tokens before a tagging. We have a POS tagging assignment, which will identify the syntactical category of each token. And the phrase chunking. Phrase chunking is nothing but it use tag pattern to extract nouns, and it just chunk the like it take out the phrases like the noun phrases or the verb construct or verb phrases. Filtering. It will remove stop words to enhance indexing and feature selection. We also have the customization as a function which does adapt the tagging pipelines to specific domains or tagging schemes for specialized IR applications. The challenges and future directions. So despite its usefulness, POS tagging faces challenges such as like contextual ambiguity, domain specific vocabulary, and resource scarcity in low resource languages. So words like lead, like which can be verb or noun, and can, which can be verb or modal, so often require sophisticated models to disambiguate accurately. So future directions include development of lightweight multilingual POS taggers, which can be which are useful to optimize for IR tasks, and better integration with the deep learning models, uh, and improved adaptation to domain specific data such as medical or legal text. So advancements in self-supervised language and large-scale languages such as BERT or GPT are expected to further enhance the accuracy and generalization of POS tagging in IR context. The challenges include a domain adaptation, tagging ambiguity, and handling low resource languages. Future resource so Future trends focus on lightweight, multilingual, and domain adaptable models. So that those are the challenges and few this one. Next one. So the conclusion. So finally, POS tagging improves how search system reads and understand language. It helps us it helps us to support smarter query expansion, better indexing, and accurate ranking. Deep learning models such as BERT have boosted tagging accuracy and context awareness. It's also helpful in useful in multilingual and domain specific IA systems. Ongoing research to aims to reduce errors and enhance performance across languages and topics. And I also have the some of the citations. And thank you.